Hey people. Okay, so I'm going to finish this up by talking about shading again. Um, but we've learned about the general problem of shading, of coloring these pixels. We've learned about lighting, the Phong lighting model. I'm going to show you now another part of the problem. So it's this. Another part of the problem is this. Let's say I have a triangle mesh, okay, like that. Doesn't really matter. Now what happens is typically we only calculate the color at the vertices, especially for something like Phong, which, well, not anymore, but in the old days was a little expensive to calculate. So you might have all these pixels that are colored at the vertices of the triangle, and you need to fill in the whole triangle. The basic method is, use vertex. Oops, I'll put it over here. The basic method is you might use the vertex color or the average, for example, and flat shade the whole triangle. That's certainly what games did for a long time. It's a basic way to do shading. Now, again, an old technique is Gouraud shading that I want to introduce. Gourau. Gouraud. I don't know how to say his name. Gouraud shading. And this is a technique that helps to compensate for the fact that we have these limited pixels. So, use vertex color. Yeah, I actually should write out what I said. We often only calculate color at vertices. Of course, I think often might be a bit of a wrong word these days. I think these days are over, with graphics cards being what they are now. But I still think it's important to learn this. And what we do is, with Gouraud shading, instead of flat shading like I've talked about, as we fill the triangles, we interpolate. Right? So if I have yellow here, I add some yellow and less, and I mix the green in, and I mix more green in, and you get this color, this blending across the triangle, and that's how we shade it with Gouraud shading. So we interpolate the color smoothly across the face. So what we do is, one, calculate shading at triangle vertices. 2, we blend them. Now what's really cool about this technique is that we can blend the results using something we've already learned. We use the barycentric coordinates. Remember I showed you the picture of the red, green, and blue blending together? Well, you don't need to pick red, green, and blue. You can pick whatever color those vertices have and just blend them together, multiplying by your U, your V, and your W, and you'll get a really nice, smooth blend. It's kind of outdated now. It's old. It's simple. It's limited. You can't modify the blend easily. Excuse me, if you want to favor one side over another. It's not. You can do it, but it's not built in. Limited, and you get banding effects due to limited interpretation. Limits of bit depth as you interpolate, and they'll line up just right, and you'll get this banding effect. Even though in the dimension it's interpolating it looks smooth, they all line up just at the wrong spot, and you get this band come out of it. So let me show some slides on Gouraud shading. So here's our Phong lighting model. So this is Gouraud shading. You see here we have flat shaded, like I said. You set the whole object the same color as the corners. And then just by interpolating those triangles corner to corner to corner, look how nice that looks. So there's no more triangles here. There's no additional triangles. The geometry isn't better. You just get this smooth effect by interpolating. Now, it's hard to see here, but there's a little bit of banding starting. There's a line right there. There's a bit of banding starting already. But this is actually a pretty nice example. As I said, it's linear. This is Gouraud shading where like it's really linear. And as you can see, it looks slightly different. This looks more like plasticky and fake. Whereas this is not quite linear. It's darker at the bottom and the darkness bunches up. So this is a little more realistic, and Gouraud shading doesn't do it. So there's other methods we want to use which lets us do more of that kind of stuff. And here's an example of Gouraud shading with Phong lighting. So we use our Phong model to calculate the colors at the corners, and then we interpolate using Gouraud, and so you get this nicer effect. Phong gives you the specular and the diffuse. You get all those properties, but you get this really ugly banding-ish triangle thing that happens with Gouraud shading. And the reason this happens is because the specular, which should be contained, it'll spread to the edges of those triangles. It bleeds out your speculars. So it looks okay. You get a little bit of specular here, but it definitely looks dated. Okay, that was slides. Where's my friggin' thingamabob? 23 to 25. Okay. So that's Gouraud shading. I'll quickly show one more and then we'll be done. I'm going to show Phong shading. This has caused no end of confusion for poor students. Yes, there's Phong lighting model and there's Phong shading. The slide I just showed, this is Phong lighting with Gouraud shading. Phong has the light model. We do all the specular stuff, cool. We only do it for the corners of the vertices, and we shade linearly using barycentric coordinates. That's Gouraud shading. Now let's learn about Phong shading, which came out surprisingly by the same guy at the same time. Okay. Not Phong. My notes say not Phong shading. Yes, Phong shading is Phong shading. It's not Phong lighting. And it's actually really clever. I like what they've done. Him, I should say. So what you do is, imagine now I'm taking a cross section. Here's my surfaces. And imagine currently I have my normals. Right? Now, these are my normals for my triangles. And currently we use each triangle, we use the normal, we calculate the Phong, we interpolate, use barycentric coordinates, and we get the slide I just showed. What Phong realizes, well, let's actually give normals for the vertices instead. Let's average these two and average these to get these. Let's average them so I get this average normal that points straight out of my surfaces. That's the first step. What did I write here? First step is we calculate the normals at the vertices. Okay? And then, whereas with Gouraud shading we interpolated the color, Phong instead, let's see if I can pick another color, interpolates the normals. Across the face. So instead of having one normal per triangle, bam, 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 normal, okay, you interpolate the normal across the face so it's smooth. And then you use this interpolated normal to calculate each pixel. And this looks really nice. Let me show you what this looks like. So again, Phong lighting with Gouraud shading. We once per triangle. These triangles aren't so big either. They're pretty small, but you see that funny effect you get. And I'm in the wrong window. Here, this is Gouraud shading. Look how bad the resolution of this diagram is with these huge quads, but look how good it looks with the Phong shading. This is the exact same mesh. This is the exact same result. The difference is we're interpolating those normals to get that nice smooth effect with a lot fewer triangles. So it slides with this. Okay. Oops. All right, we're done anyway. Slide 26. So that's it. We're done. Done like dinner. And that's all we're going to learn about shading those pixels. Thanks.